Good morning. In this case study, we see about a gyroscopic couple. So, what is meaning of gyroscopic couple? A gyroscopic is a device to measuring or maintain the orientation based on the principle of angular momentum. In mechanical, a gyroscopic is spinning wheel or disc in which the axial is free to assume any orientation, although this orientation does not remain fixed. It is changes in response to an external torque much less than the different direction than it would be without the logged angular momentum associated with this high rate of spinning and momentum of inertia. So since the external torque is minimized by the mounting the device is a gimbals, the orientations of remains nearly fixed, regardless of any motions of the platform on which it's mounted. So here, the the gyroscopic frame is over here. There is a spinning axis. This is a rotor. So what is the precisional angular motion? Vectorial representation of angular motion. We know that the angular acceleration is the rate of change of angular velocity with respect to the time. It is a vector quantity and may be represented by the drawing a vector diagram with the help to the right hand screw rule. So let's assume the spinning axis, we are rotating the disk is at a velocity of angular velocity of omega in a direction of view at x direction from the front view of the disk. On the new axis of rotation, we denote as the OX dash. It is rotating at a speed of omega into del omega. So the both the axis of the spin and new axis spin is making angle of del theta. So from this space diagram, we represent to the vector diagram. Here, OX is called as axis of OX of vector diagram is represented as OX, that is denoted as omega. Similar, OX dash in a space diagram, we represent in a vector diagram. Here, the OX dash, that is called as my velocity diagram, that is omega equal to del omega. Similarly, joining the X dash and the R, we getting the omega plus del omega minus omega. Consider this figure as shown. That is a figure is a revolving and spinning about the axis of OX. That is known as the axis of spinning. Yes. So where d by dt is the angular velocity of axis spin. In a certain axis which is a perpendicular to the plane in which the axis of spinning is going to rotate. This angular velocity of axis of the spin is known as angular velocity of precession and is denoted by omega p. The axis about in which the axis of spin is turning is known as axis of precession. The angular motion of axis spin about the axis of precession is known as precisional angular motion. So from this case, we have take the notes. That is, the axis of precision is perpendicular to the plane in which the axis of spin is going to rotate. If the angular velocity of the disk remain constant at all the positions of the axis of spin, then d theta by dt is 0, thus alpha c also 0. If the angular velocity of the disk changes in the direction but remains constant in a magnitude, then the angular acceleration of this is given by alpha c equal to omega d theta by dt. That is denoted as omega into omega t, where alpha c is called as is known as gyroscopic acceleration. So what is meaning of gyroscopic couple? Consider a disk, a spinning with the angular velocity of omega, that is SI into radian per second, about the axis of OX in an anticlockwise direction when seen from the front view of as shown in figure. Since the plane which the disk is rotating is parallel to the plane YOZ, therefore is called as plane of spinning. So here the plane XOZ is a horizontal plane and the axis of spin rotation plane parallel to the horizontal plane about an axis of OY. In the other words, the axis of spin is said to be rotating or processing about an axis OY. In other words, the axis of spin is said to be rotation about an axis of OY, which is perpendicular to both axes of OX and OZ at an angular velocity of omega p, that is a radian per second. This horizontal plane XOZ is called as plane of precision and OY is called as axis of precision. So from this lectures, we see about I is equal to omega, that is called as angular momentum of the disk. The I is called as mass moment of inertia, where omega is called as angular velocity of the disk. Since the angular momentum in this vector quantity therefore may be represented by the vector of OX as shown in figure. The axis of spin OX is also rotating anticlockwise when seen from the top about the axis of OY. Let the axis OX is turned in a plane of XOZ through the small angle del theta radiant to the position OX dash. In this time, del t seconds, assume the angular velocity of omega to be constant. The angular momentum will now be represent the vector of OX dash. So change in angular momentum, we consider OX dash minus OX. So we written as OX x into del theta. So the rate of change of angular momentum that to be written as I omega into del theta by dt. Since the rate of change of angular momentum will resulting by the applications of couple to disk. Therefore, the couple of applied to the disk causing the precision that is denoted as C equal to I into omega del theta by dt. That is final formula of couple is equal to I into omega p, where I is called as mass moment of inertia, omega is called as angular velocity, omega p is a precision angular velocity. That is a SI unit of C we call it as Newton meter, where I is SI unit is called as kg meter square. So let's discussing about one problem. A uniform disc of 150 diameter as a mass is 5 kg. It is mounted centrally. The bearing which is maintained its axial in a horizontal plane. The disc spin about the axial with a constant speed of 1000 rpm, while the axial precise uniformly about the vertical at 60 rpm. The direction of rotation as shown in figure. If the distance between the bearing is 100 millimeter, if the resultant reaction at each bearing due to the mass and gyroscopic effect. So from this the question, we have to take the given data. So what are the given data given this question? The diameter is equal to 150 mm. We convert into radius. That radius value in millimeter, so that we convert into meter. So then the next they are given the mass value that is 5 kg and RPM n is equal to 1000 RPM. So where omega is equal to 2 by 1000 by 60, that is equal to 104.7 radian in the anti-clockwise direction. The speed of precision is to be given in 60 rpm, so that from we have to find out the speed of precision from this omega is equal to 2 pi n by 60. From this formula we have to apply the n value here. We find out the omega p, where omega p is value is called as 6.284 radian per second in anti-clockwise direction. So the x value is given in 100 millimeter, so that we convert as a 0.1 meter. So from this given data, we have to find out the mass moment of inertia of axis through the center of gravity and perpendicular to the plane of disk. That is quite as I is equal to m r square by 2. We substitute in the data m instead of m is equal to 5, r is equal to 0.075 the whole square by 2. We getting the moment of inertia, that is I is equal to 0.014 kilogram meter square. So due to the gyroscopic couple acting on the disk, so C equal to I into omega p. Whereas I is we have to already find out from the previous case, that is 0.014. Substitute in this formula, then omega is equal to 104.7. Then omega p is given already find out in given by using of given data. That value is 6.284. So the C value of the disk is called as couple of disk value is called as 9.2 Newton meter. The direction of the reactive gyroscopic couple as shown in figure, let the F be the force acting bearing due to the gyroscopic couple. So F is equal to C by X, where C is equal to 9.2, X is equal to 0.1. So we getting the force value. So what is the force value? We have to getting 92 Newton. Therefore, the force will acting on opposite direction at the bearing of shown in figure. Now let RA and RB of the reaction bearing be A and B respectively. Due to the weight of the disk since disk is mounted centrally in the bearing. Therefore, RA RB is equal to pi by 2. So they have equally divided the mass value. That the mass values of RA RB is equal to 2.5 kg. So we convert into Newton, we product with this value into 9.81, we're getting the Newton value. That value is 24.5. So the resultant reactions of the each bearing, that is RA1 plus RAB, RB2B1, is a resulting reaction of bearing A and B. So we need to find out the RA1. We have to add the summation of force plus RA. We getting RA1. Similar, RB1 we have to find out the summation of F plus RB. We find out the values. That value of RA1 is 116.5 Newton, where RB1 is quite a 675 Newton. So RA1 is acting at upward, RB1 is acting at a